In this section, we're going to take a look at report performance and design with a focus on Report Studio. We'll take a look at filtering with indexes, which is a basic concept, and then look at some tips for dimensional filtering and an examination of some commonly seen mistakes. We'll look at query strategies, then we'll take a quick look at query properties, and then a look at how to troubleshoot reports. Again, there are so many scenarios that we can't possibly cover them all. The intent here is to just show you some common things that the support organization runs into, and also give you some tools to teach you how to troubleshoot these issues on your own. Although this may be considered a basic concept, it is worth repeating. It's highly recommended to filter on indexed values rather than non-indexed string values. So in this particular example, the use value would be product line code, an indexed integer in the data source, and the display value would be product line. This is the same example as seen in the Framework Manager section previously. Let's go into Report Studio and quickly take a look at how to set up this type of filtering. Here in Report Studio we have a simple list report consisting of year, product line, order method, and revenue. And our end users would like to be able to filter on product line and order method. Now in the Framework Manager model, product line has its prompt info properties set accordingly, but order method does not. And what we'll do is build an automatically generated prompt page for these two items by selecting them both and clicking on the Build Prompt Page button on the toolbar. This will create a new prompt page with two prompt controls, one for each of the query items. And in the background create two new queries, one to supply values for product line and one for order method. Let's look at the product line query first. We look at the use value and see that it is indeed product line code that is being used as specified in the Framework Manager model. And the display value is the item itself, the string value for product line. Now if we look at order method, the use value is order method, the same as the display value. And this may cause concern for performance. So to rectify that, we can change this value by double-clicking it, editing the expression, and replacing it with order method key or order method code, depending on which one is more appropriate in this particular scenario. And then we need to go back to the main query that the list is based on and change the filter that was applied when we built the prompt page. And we have to change the filter from using the order method to using the same item that we specified in the use value in the order method query. So now when we generate our SQL from the Tools menu, Show Generated SQL or MDX, and look at the list query, we'll see that in fact product line code is being used in the filter and order method key is being used in the filter, and we are going after integer values as opposed to string values. Sticking with the themes of filtering, let's take a look at some do's and don'ts for dimensional filtering. First off, one of the most common things we see is the use of relational filters against dimensional sources. Now this is not recommended, and it is well documented in the core documentation. We highly recommend you read the differences between relational style reporting versus dimensional style reporting. One of the items that I'd like to show you in the following demo is using UI suppression versus using the filter function. Now, the filter function is a dimensional function that can be used to focus your dimensional data. Lastly, we'll look at using slicers versus specifying a member in the report layout. In some instances, people will put a product line in the report layout and then slice on product line with a product line member. And we'll show why this may not be such a good idea. So first, let's take a look at using UI suppression versus using the filter function. Here in Report Studio, we have a simple report. It's a crosstab report with year on the rows, and nested under year is quarter, and on the columns we have product line and a default measure of revenue. And when we run this report, we'll see that we have an entire row of null values for Q4 of 2013. So we have a couple of options. We can use UI suppression, and you'll see that this removes the null rows. But what's interesting to note here is that that suppression is done locally. So all the data is retrieved from the data source, and then we suppress the null rows and columns locally on the Cognos BI servers. And to see that, we can go and look at the generated MDX for this particular query, and we won't see any filters in this particular syntax. We're retrieving the entire data set and then suppressing it locally. Now we'll take off the suppression and use another method where we'll create a calculation, and within this calculation we'll filter the quarters where revenue is not null. So we'll type in the filter function. You can also grab that from the filter functions tab as seen here, and when you select any of the functions in this pane, you will see tips on that and what the syntax needs to be for that function to perform properly. In this case, we'll put in quarter after an open bracket, and we'll put a condition in where revenue is not null. So now when we run the report, we'll have the same effect where the null row is removed from the output. But this time when we look at the generated MDX, we'll see that the filter is in fact pushed down to the data source, and no local processing is occurring in this particular scenario. Now again, in some cases, using null suppression can hinder performance, especially with large data sets, and in such cases consider using the filter function. Here's another scenario where product line is in the layout. So we have product line on the columns, and sometimes we'll see authors adding a slicer based on an item that's already in the layout. So in this case, product line, and we'll grab the camping equipment member and then run the report. And what occurs in this scenario is that we just get the slice of camping equipment and null values are returned for the rest of the items. And then what we typically see is that the users will suppress the columns to remove all the null values. And now we're back into a local suppression scenario, which is unnecessary in this particular case. So alternately, we can remove the slicer and in the report layout, remove product line and simply add in the member that we want, which gives the same effect without any suppression. And of course, to make that a little more dynamic, we can simply add a calculation, which will make a set expression. And then using dimensional filter syntax, we will filter on product line, or put in place a parameter that will ask for a product line. Now at runtime, users will be prompted to select the product line they're interested in, and only one column will be returned. And of course, to do multiple selections, we can edit that expression again by editing the set definition and writing in the set expression, which will say that we want to bring back multiple values for this particular prompt. And now when we run the report, we have the option to do multiple selections. Again, no suppression is required, and this can help improve performance by returning only the members that are required for the report. In this next demo, we'll take a look at query strategies where singleton queries are concerned. The first one we'll look at is singletons versus queries associated to a page for free-form layout. Often people would like to display their data in free form rather than using a list, report, or a chart, or a crosstab, and independently place data items where they wish on the report. The second item we'll look at is using singletons to display selected prompt values, and how there's a lot of overhead using singletons rather than using a param display value in a layout calculation. Here we have a report with 2 pages. The first page uses singletons for free-form layout, as can be seen here. 1 singleton for year, 1 singleton for product line, and 1 singleton for revenue. The second page has a query associated to the page. So if we select the page and use the ancestor to select the overall page body, we'll see that query page layout is the one query associated with this page, allowing us to freely lay out the query items on this page. The limitation to this technique, however, is that you can only associate 1 query per page. Now let's run the report and take a look at the effects. So this is the first page, and you can see the free-form layout here. And if we go down to the second page, we'll see the exact same effect. The free-form layout is the same. Now let's take a look at the difference, though, in how many queries are sent down for each of these techniques. If we go to the Tools menu and go Show Generated SQL in MDX, for the first page we can see that 3 separate queries are being sent down to the database. And for the second page, we can see that only 1 query is being sent down to the database. So this, in and of itself, can improve performance dramatically. So here we have another report using a singleton, and in this case the singleton is being used to display a year that was selected in a prompt on a prompt page. We'll examine this report quickly and see that there is a prompt page that has a year selection prompt. That prompt is based off of a query called query year prompt. The report page has a list on it that is based off of query list, and then this singleton, which is based off of query singleton year display. Now this particular query presents 2 problems. A, we're using a singleton to display something that we could use a parameter display value instead. And the other issue with this particular query, if we go and look at it more closely, is that we'll see that this data item is actually based off of an item from another query, in this case query list. Therefore, query list will be a subquery to this particular query. And to see the effects of that, let's look at the generated SQL. If we click on query singleton year display, we'll see quite a large query. In fact, this looks quite the same as the query that was used to populate the list. So a lot of unnecessary processing is occurring here. So one way to reduce the amount of processing that's going on, instead of using this particular query, query singleton year display, let's point it to query list. And then instead of displaying the selected year, we'll go in and display the year instead. Now when we look at our generated SQL, we'll see that query list generates 2 queries. One for the singleton, which this time is much smaller, and then one for the list. But again, this query is completely unnecessary. So let's get rid of the singleton altogether and use a layout calculation to display the parameter value. All we need to do is go to our Parameters tab. We have a year parameter in this report. We put it in the expression definition. Click OK. Run the report. And the effects are identical. The year is displayed here, but rather than having an extra query altogether, if we look at the generated SQL, we'll see now that we just have a query for our prompt and a query for the list.